In this video I'm going to show you how you can change the pitch settings in PRAAT so that the line that you see, the blue line that you see in the analysis window, is a little bit closer to and more realistic to what we hear in everyday life. I've taken out a little part of one file. It is a little bit broken, but it sounds like this.
That must be really great.
That must be really great.
That must be really great.
You can hear some of the has been cut off, probably somewhere around there. But it's got quite a nice pitch trace, and that's this blue line here. But you can see that it's also relatively flat, and there's a reason for that. In fact, there's a couple of reasons for it. And there's things that you can do to make this look a bit more obvious. And the way to do it is to go up to the pitch menu at the top and choose pitch settings there. And now there's two things that you can change. One is the pitch range and the other is the unit that's used to display. The pitch range comes at 75 to 500 Hertz as a standard, and for most purposes that's fine. But if you think about it, most male speakers don't get that high with their F0. They get to maybe 300 or 400 Hertz. That would be a reasonable estimate of the upper limit. For a female speaker, 500 might be a little bit too low. So what I'm saying is you might want to have different ranges for male versus female speakers. I'll just show you the effect of doing this. So I'm going to change it to 300 Hertz as the upper. And if I press the apply button and you watch the blue line, what you should see is that the blue line jumps up. Now the unit that we've used is the Hertz scale, and the Hertz scale is just a linear scale, which isn't really the way that we perceive pitch. We perceive pitch in a more logarithmic scale. That's to say, we perceive it so that the relationship between 100 Hertz and 200 Hertz is heard as one octave, a doubling of the pitch. And the relationship between 400 Hertz and 800 Hertz is also a doubling of the pitch. And it's the same auditory relationship, and you can see that better on a logarithmic scale than on a linear scale. So the next suggestion I would make is that you change the unit from Hertz to Hertz logarithmic. That's what I'm going to do. You can also use semitones if you like, but I'm going to just stick with Hertz logarithmic because I quite like knowing the Hertz values. So again, watch what happens when I apply this. You should see that the distance between the peaks and the troughs gets a little bit bigger. And there you go. We'll say OK to that.
That must be really great.
And now you get a much better sense from looking at the blue line that overall this man's pitch has a declination line. That's to say it starts high at the beginning and low at the end. We call that declination in intonation studies. And you can also see that the high pitch at the beginning is quite high. You can hear that it's relatively high pitch for him, and it looks much higher up on the scale on the blue line. If you want to just check what the Hertz value is, all you need to do is to click somewhere on the blue line and read across to the right, and the number on the right in blue tells you what the F0 value is. So at this point here where I've just clicked, it's 142.8 Hertz. The number in red on the left is the value that is being applied to the formants that you can see there. So you can see that there's a formant quite at about that same sort of level. Okay, so that's how you can better see pitch traces in PRAAT.